we go. All right. Let's hope that what I'm about to share with you will not only blow your mind, because that's the goal, not only blow your mind, but I hope that what I am about to share is also going to, you'll be able to soak it in like a sponge and think about how it can help you in your quilting journey. So, what is it that I'm talking about? Well, it's a topic I have been fascinated by for quite a while now. I probably was introduced to this concept. I'm sure I learned some of these things in college. I don't quite remember. I mean, do I remember anything from college? Not a whole lot. But I'm sure I learned it somewhere down the road. And it's a mathematical concept, and it's actually really quite a phenomenon. And so I've been fascinated about it for, like I said, probably the last year. And I told the ladies here, I said, I think I'm going to talk about the golden ratio. And they're like, what? The golden ratio? And I was like, yeah, the golden ratio. Have you heard of the golden ratio? Do you know what it is? Do you understand the concept of it behind it? It really is quite incredible, and it's very, very fascinating. So I'm going to break it down into bite-sized chunks because, interestingly enough, this concept is, what word should I use? It's like it's timeless, and it is something. Yes, Diana says yes, and it's very important. It's so true. It's like it will blow your mind when you realize how it's an irrational number that continues and continues and continues forever. Like it never stops. Okay, so that's the first thing to think about. Yep, yay. Oh, Heidi just watched a program about the golden ratio. And Kim Close is saying the algebra teacher in me is loving this topic. Yeah, it's fascinating. And so it's one of those things. The golden ratio is something that has been around since the time of the ancient Greeks. It's an irrational number. Another term for it would be called, like sometimes people call it the golden mean or phi, but it goes on forever after the decimal point. Okay, stick with me, guys. Stick with me. All right. So I'm fascinated by it. It is something that not only do engineers use, artists use, any kind of graphic design uses it, buildings, architecture, technological themes, but also the very essence of nature uses the golden ratio. The golden ratio is found all across nature. It's found in our bodies. It's fascinating. Okay, so let me do a little bit more explaining. Okay, yeah, it's like to infinity and beyond, right? So let me bring up some pictures here. Yes, music. Yes, Melaine, music. It's found. The greatest composers, the greatest artists, the greatest Leonardo da Vinci, these people of all time have always used the golden ratio. And interestingly enough, if the same goes for our body, okay, let's take for our bodies, for example, okay? Our bodies are in perfect form. It's like there is a golden ratio that goes from, if we were holding out our arm, okay, well, you can't see my arm here, from your shoulder to your elbow would be like 1 unit, and then from your elbow to your fingertips is 1.6. Okay, it's 1.6, so it's a little bit more than halfway larger than here. Okay, so again, shoulder to elbow would be like 1 unit, and elbow to your fingertips is 1.6, a little bit more than halfway. Okay, the same goes for our fingertips to our wrists would be 1, and our wrist to our elbow is 1.6. From the top of our head to our navel would be 1, and our navel to our tippy toes is 1.6. We see it in our eyes. We see it from here to here. It is unbelievable. Like I said, it's fascinating to me. The more I have studied it, the more I have just had my mind blown. Okay, so perfect nature. This is what we find in our bodies. Let me bring up a couple of pictures here, because we also see this golden ratio in nature. Yep, Sue, you are exactly right. I'm going to show it is 1.618, blah, 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 and it continues, and it goes on and like to infinity. Okay, so 1.618. Okay, stay with me because I'm going to tell you how this relates to quilting. I promise it relates to everything, right? So we see it in nature. Let's take a look at, I brought some pictures here to show you today. Oh, well, let me show you the mathematical formula. Okay. A plus B is to A as A is to B. Unbelievable. Okay. So what does that exactly mean? Well, let's take a look at this shot. You have this center that then goes out, and from the next point of petals is times 1.6, and then you go to the next one and it's times 1.6 and 1.618 and 1.618 and 1.618, and this grows from the center. Okay, let's take a look at another picture here that I found. Okay, so let's say that in nature you have 3 petals. The next set of petals is 5 petals, then it goes to 8. If you were to multiply 3 times 1.618, you're going to get 5. If you go 5 times 1.618, you'll have 8 petals. If you do 8 times 1.618, it's going to give you 13 petals, and so forth. Trust me, guys, when I say this, that if you begin to look all around you, and not only with our bodies, but the nature around us, the galaxy, it kind of gives me the goosebumps. Does it give you the goosebumps? It gives me the goosebumps. Okay, so I want to show you. It's just a few minutes long. I don't know if the music is going to work, and if it doesn't, I'll be really sad. But I came across this video because that is the golden ratio. It's about 5 minutes long. I probably won't show the whole thing, but I do want to show part of it, okay? Because, and if you don't, there's no words to it. It's just music. So if the music doesn't work, it's all good, okay? But it's going to show you that one unit to 1.6 to 1.6 to 1.6. Yes, Janet, Fibonacci, Kim, Fibonacci. It's very close to Fibonacci. In fact, when I was doing my research, Fibonacci, that's a whole nother thing, and I get kind of geeked out about this stuff. But Fibonacci would be like if 1 plus 1 is 2, and then you take 2 plus 1 is 3, and then 3 plus 2 is 5, and 5, okay, there's a sequence that follows. And so it's very similar to Fibonacci, but the golden ratio, the golden ratio actually happens about after the 10th number of Fibonacci. Okay. All right. I know I'm so weird, but it really, like I said, this has to do with quilting, and it's going to just like all of a sudden you're just going to go, oh my goodness, I'm learning something so cool, so new. Okay. So let me share my screen, and it's beautiful. If for some reason the music doesn't work, I will repost the video later in the Facebook page. Okay, so you can listen to the music because it's actually gorgeous classical music. Okay, let me share with you. Okay. Wow. Wow. Is that amazing? I mean,
As small
I don't know
towners,
about
we've
you.
always had a heart for the heartland, which is why we're excited to join T-Mobile's Hometown Initiative.
As the leader in 5G, T-Mobile is investing billions in 5G upgrades for small towns.
Trying to get rid of that. Okay, there we go. Unbelievable. Yes, Roxana, in the universe, everything fits together perfectly. I totally agree. And that's what is so mind-blowing. Like, I'm just like, can you see why I'm kind of geeking out over this stuff? And so, the more you look around you at architecture, at art, at music, at nature, at our bodies. Another thing, I was pointing out to you from like fingertip to elbow, from elbow up here, the same with our knuckles. If you look at your knuckles, okay, from one knuckle to the next one is 1 unit, but then from the knuckle up is 1.6. It blows my mind, okay? So, it is just absolutely beautiful. Are you guys making fun of me? I think some people are teasing me. You're really measuring. Like, really? I know, it's crazy. So what does this have to do with quilting? Well, it has everything to do with quilting. In fact, framers know this. People who are artists know this. And so, have you ever looked at a quilt, okay, and thought to yourself, something just doesn't look right. The proportions might be off, okay? So then Jenny Beyer, okay, a lot of you know Jenny Beyer. This is where also I became fascinated with her study of the golden ratio when it comes to quilting. And you think about it, sometimes when you look at quilts, something is just not quite right. And so you're trying to figure out, what is it that's not coming together, right? And a lot of it has to do with proportions. And so oftentimes when we make a quilt, we're doing it based off of a pattern, and we think, we like it. It looks pleasing to the eye. A lot of times we'll do some guesswork, but then there will be quilts that just absolutely, you're just like, wow, something is harmonious in this quilt. And oftentimes, if that's the case, what is bringing it together in a harmonious manner is the golden ratio. Okay, so how do you figure it out? Oftentimes people say, I don't know what to do for my sashing. Like, I have all these blocks. Maybe you've inherited blocks. Maybe you got them at an estate sale. Maybe you have a whole bunch of UFO blocks and you want to put them together, and you're like, I don't know. Should I do a 2-inch sashing? Should I do a 6-inch? What should the border be? Okay, what should my inner border be? How large should it be this? Well, if you apply the theory of the golden ratio to your work will be a true masterpiece. Okay, it will look really good. Some might go, Kris, I just will look and see. If it looks good, great. I'm fine with it. And you know what? That's totally fine too. You absolutely can do that. If you like it, there's no one saying, well, that's not the golden ratio that you're using. But if you really want to get mathematical about your quilting and have everything be proportionally correct, apply the golden ratio. So what is it? You multiply whatever number you're trying to go, to extend, you multiply it by 1.618. Okay, 1.618. Okay, write this down. If you're keeping a notebook from 3 at 3 videos that we do, write it down. 1 times, well, whatever the number is, times 1.618. Or let's say that size is too big. I'm going to give you an example here in a minute. Let's say that size is too big. You could take off the 1 and do whatever that number is, and you multiply it by 0.618. You will still have something look proportionally pleasing to the eye. Okay, so you could do 1 times the 1.16 or 1.618, or you do 0.618. So what am I talking about? Well, today we just got these panels in that are absolutely adorable, and a lot of people love panels and they want to add borders to them, but they're not sure, like, should I do a 5-inch border, should I do a 10-inch border, right? So there's different ways, if you want to be mathematical about it, to do that. So that's what I did with this panel. So Jenny showed me this panel this morning, and I was like, oh my gosh, that's perfect for trying to figure out, and to give you an example. Boy, my office is a mess, isn't it? To give you an example of the golden ratio. Okay, so let's take a look at the panel, and then I'm going to walk you through how I figured this out. Okay, is that the cutest panel? Oh my goodness, it's this brand new little alphabet panel. We have them in pink and blue. Pink and blue. Okay, I think it is so sweet, so sweet. Okay, look at those little, the little mermaid. And I love panels. If you're looking for a really quick and easy gift to make, pick up a panel. Look how cute the llama is. Oh, and the kitten. This is just, oh, the giraffe. Oh, the hedgehog. Oh, stop it. So dang cute, right? So we have them in boy and girl panels. So the question is, what size should I add my borders? What size should my borders be? Well, let me take you through this. First of all, I added 2 additional borders. This border is already built into it. Okay, so that's part of the panel. What you see right here is built into the panel. Okay, so what I did was I measured that. So let me move my screen down here. Oh, do you have something to show us? Oh my gosh. Okay, you have to look at what Jenny, that is so cute.
It is cute, isn't it? I was just showing you the backs.
Okay.
So you have them to show.
Look at that. Oh my gosh, is that so cute? Oh, this is the little boy version.
Here, that was the girls.
Here's the panel. Here's the colors that you're seeing.
This goes with the boy one. I don't know if you need to show them that.
I could. Look how fun that is. Oh, the moose. Oh my gosh. Yeah, and the moose, there's no mermaid there. It's a moose.
And they should be good to go.
Oh my gosh. Thanks, Jenny. You have the girls on there too?
Yep.
Okay. So let's take a look. Debbie said she usually does the outer border 1.5 inches of inner, so she was close. Yeah, absolutely. Like I don't want you to feel like you're doing something wrong. Okay, but if you like it, if it's pleasing to the eye, then it's all good. Okay, so here we go. Let's talk about this. Let me grab my phone because I want to do the calculations here in front of you. So when I measured this inner border right here, it came out to be 1 inch. Okay. But I knew that I had to add in the 1/2 inch, 1/4 inch on both sides. So really this, as being finished, is 3/4 of an inch. What is 3/4 of an inch in decimal? It's 0.75. All right. So what I did was I multiplied 0.75 times the golden ratio, which is 1.618. That gave me 1.21. Well, let's round that up, shall we? Let's round it up to 1.25, which is 1.25 inches. Okay, this is 1.25 inches. We're rounding it up for our quilting. Okay, so 1.25 is the closest, but I have to add 1/4 inch to both sides, so I need to add 1/2 inch more. So I hope I haven't lost you. So 1¼ inches plus a ½ inch is going to give me what? It's going to give me 1.75. That's 1 3/4. Okay. So that's what I cut my next border to be, because I had to account for seam allowance. So I cut it to be 1.75, knowing that when it was all sewn together, it was going to be 1 3/4. Okay. So this is what I did here. My next inner border that I did was 1.75. I cut it to be. All right. And then from there, I needed now my outer border. Okay. So what I did, there's a couple things you could do here. You have two choices. You could measure just the border next to it, or if you like wider borders, you could measure both of these borders together and multiply it by the golden ratio. All right. Well, I wanted to do both. I liked a little bit wider border, right? So rather than just measuring from here to here, I measured both at the same time. So what was that? Let's see. That's 2 inches finished. Okay. So I'm going to add a ½ inch. So I've got 2.5 times 1.618, and that gives me 4.04. Okay. Now, oh, excuse me. Yes, I could do that. So I could cut it to be a 4-inch border and then sew that on. Okay, so because that's the closest here, and just sew it on. I could, if I wanted to, if I wanted it smaller, again, I could just base it off of here. If I wanted it larger, I could base it off of here. If I wanted it smaller based off of this, I could multiply it by 0.618 and not the 1.618. Okay. Either way, it's all going to be proportional. That's the key here. It's all proportional to one another. So what happens, it ends up being very pleasing to the eye. Okay. I hope that makes sense. If this fascinates you like me, then you can, that's something to look into and go, hey, I want to learn more about that. I want, and then look it up and do a Google search, and you will be going down a rabbit hole like Kris was, because it was so intriguing to me. Yeah. So you would cut it to 4.5 inches to finish at 4. Yes. Yeah. So that's how the golden ratio can work with our quilting. Isn't that amazing? The same thing that works with nature, with the universe, with our bodies, with engineering, with architecture, with artistry. We can do the same thing as quilters. It really is amazing. So 1.618 is your magic number. And then you're going to multiply it. You kind of raise it to where it needs to be, and then add a ½ inch. All right. So I hope that gave you something to think about. And again, if some of you are like, nah, I'm just going to eyeball it. You know what? That's okay too. That's totally okay too. Now, think about this. If people are wondering, what should I do for my sashing, right? Have you ever wondered that? Sometimes our go-to is we go, oh, I'll do a 2.5 inch sashing between each of my blocks. Well, it could work. I mean, absolutely. But maybe you think about something else and go, you know what? I want to play around with these numbers and see what might work. So here's an example for you. Let's see if I can do this in a nutshell. Let's say you have 6-inch blocks. Okay, they finish at 6 inches. So I could multiply 6 times 1.618. Let's do some math here and see if I'm correct on this. 6 times 1.618. Okay, that gives me 9.7. All right, so I rounded up to 9.75, so it's 9 inches, 9 3/4 inches. Now, am I going to have a 9 3/4 inch sashing around all of my 6-inch blocks? Heck no. No, that's too big, right? That's okay. What you're going to do is you're going to divide it by 4, because you have 4 sides to the block. Okay, so let's see what happens. If I do 9.75 divided by 4, that gives me 2.43. I could do 2.5 inch strips, right? Okay, so there you go. Isn't it amazing? So that's it. That's it. That's theme number 2. And again, you know, study it some more if it just intrigues you like it has intrigued me. Something that Jenny Byers actually sells, if you're really interested and you don't want to do the math. We don't carry this, but I'm happy to tell you about it. Is she has what's called the Golden Ratio calipers. You probably, you know, those of you who are engineering or into engineering, anything like that, you may know exactly what I'm talking about. And what it does is that you can, it's a little contraption that you place on top of like one border, and then the other part of this contraption will actually make it 1.618 larger. So you can kind of have a better visual. I didn't bring them in because I don't think like I would use them that often. But that's just me. I'm fine with just doing the math on a calculator, and I can figure it out. But if you're not and you want to look into it, then look into Jenny Byer, and she's got, like I said, she's got these calipers that calipers, I don't have tomato, I don't know. And she has these where you can do that. So it's kind of interesting, you know. It's one of those things in life that you just go, interesting. Become curious, my friends. The more curious you become about the world around you, the more fascinated you will be with the way the world works. And it is unbelievable. Unbelievable. It's just amazing. So anyway, that's the number 2. All right. Any questions? Oh, thanks, Christy. She says, make sure you go back and watch. I think somebody had just gotten on, so you're sweet. Thank you, Christy. Suzanne says, oops, there we go. As an engineer, she loves this. I hope I explained it well enough, Suzanne. I was like, how do I explain this through a theory? But maybe I do need to put together a handout or something. I could possibly do something like that. But yeah, Linda, I could probably put it on a handout. I hope I've explained it well enough to all of those of you who are engineers or mathematicians. I just think it's so intriguing. Jill says, mind-blowing. Yeah, there you go. Oh, thank you, Marilyn. The 4th grade teacher continues to live inside you. Great explanation. It's coming out. Thanks, Elisa. She put it on here. Golden ratio 1.618. Yep. Yeah, very true, Lynn. That would be interesting. She said, I would love to eyeball it and then see how close my eyeballing is compared to the golden ratio. You know what? A lot of us, because we are so driven by design, because we are surrounded by it all the time in our sewing rooms and what we're doing, I bet a lot of us could eyeball it. We could be really, really close to that golden ratio without even knowing it. So very cool. Pamela says, very cool. I was just getting ready to do some sewing math. Your timing is perfect. Fantastic. I love hearing that. Okay. Jackie loves it, but she needs more examples. Google it. You will see examples all around, and it will blow your mind. The fact, I mean, when I saw that video and I was like, even our DNA, whew, that's just incredible. Thank you, Kathy. She said she's going to try it on her next quilt. So glad to hear that. And Christy said that she is just finishing up a quilt. She was trying to determine what size to do the borders, and now she needs to rethink this. You know, Christy, it would be interesting to do what Lynn was talking about and kind of, you know, test it out on a, you know, scrap piece of fabric or just cut up a piece of paper to see how you like it visually, if it's visually appealing to you, and then go from there and go, oh, I was right on, right? There you go, Sharon. She needs to discuss this with her engineering son. Definitely discuss it with him. I'd love to hear his take on that. Wouldn't you impress your son by saying, guess what I learned today? I talked about this. Exactly. Hey, Marilyn says, now I know why I don't like that one quilt. There you go, Marilyn. So true. So true. There's always, you know, something that is just a little off, right, Debbie? It's the most aesthetically pleasing to the eye. So again, when you think about our bodies and you go from here to here and then from here to here, and then it's crazy. All right. Well, enough about that, I guess. But I hope you enjoyed that little lesson today.